Yeah, we have a good number of people. I'm gonna just be going over the review guide. I think, let's see, yeah, final exam review quizzes not graded .pdf. If any of you have access to that, or if you don't have access to that, we can possibly quickly email you the PDF. And a little disclaimer, not everything on this will be on the exam. This is at least from past exams, but there's a pretty good chance that a lot of the topics will be on the exam. So if any of you don't have access to the final exam review quiz, I guess you can privately send your email to Abby, and she will
Yeah, I
email
can
you the
email those
file.
guys then if anybody wants to send their email to me.
So we have a good number of people. So first off, does anybody have any immediate questions? Feel free to either say it in chat or unmute yourself and speak. If we don't, I can kind of go in. Any questions at all? Like if there's a specific problem from a specific homework set that you want to go over, specific topic you want to review, anything. Otherwise, I will begin on the review. Nope. You have one person. You're muted if you're trying to say anything. No?
No, not at all. You're good.
Okay. Okay. Just checking. All right. Let's see. So I can just trying to think of the best way to do this because I don't know. Oh, let me figure something out real quick because I'm trying to think if I can directly write on the sheet or not. Because normally I just use the whiteboard from Zoom, but it might help to see the problems. So
You could try opening it in Paint. I don't know.
I'm gonna try. I just downloaded Acrobat Reader. I'm wondering if I can draw on it. Yeah, that ain't it. Sorry. Nope. Okay, not gonna do that. So I'm gonna use Paint for at least a couple of the things. Let me open up Paint real quick. And then I'll start sharing my screen so we can do this. So I'll just whoops. All right, got something started and I can start sharing. I'll just share Paint. Sorry if you guys are hearing that background. There are 2 cats or 3 cats and they're fighting. So, okay. From the review, we have evaluate the following integrals using substitution. And you must write out your steps to attain full credit. So we're just going to be using U-Substitution here. So we have brushes. Let's see. will do. So for the first problem, so cosine 3x plus 7. So the way that we would do this is we always want to say the inside is the u for an equation. So we'll say u is equal to 3x. And technically, you can stop here. I always find it nicer if you just include the entire inside, because otherwise you can get lost because you'll have like cosine of u plus 7 and you might not immediately see it. And then from here, we have to calculate our du, just the derivative. Very simple way of just doing a u substitution. So we take the derivative of that, get 3 dx. And then typically from here, if you don't immediately see the derivative inside of your integral, so in this case, like we don't exactly see 3 times dx, we just see dx. It's nice to substitute it so that you can find it immediately. So we say dx is equal to du over 3. So then our integral just becomes the integral of cosine of u over 3. And that's du. So then the 1 over 3 can pop out here. Take the integral, we will get 1/3 sine of u. So we would say u here. But in reality, we know that u is equal to 3x plus 7. So we can just write that. And there's the first problem. Of course, don't forget your plus c as you're taking an indefinite integral. I'm pretty sure you will lose points on that. Maybe just 1 point, but it's a free point to remember the plus c. Just think it that way. And it gets slightly difficult. Actually have an x on the outside. But again, we just say, okay, the inside is x squared. So we say u is equal to x squared. Du would then be 2x dx. Sorry if I'm going a little fast, feel free to stop me, but do that. We don't immediately see the 2x dx here. We just see x dx. So we just want to find x dx is equal to 1/2 du. So we'll replace x dx with that. And then have the integral of 1 sine. Again, pretty to be above 1 this time because we're integrating sine. Remember that it's negative. If I cut in and out, my internet has been kind of wonky. And we'll end up with negative 1/2 cosine of, so now we have u. We can substitute it in immediately for x squared. And bam, plus c for the free point. And you have it solved. Any questions on u substitution? They're probably going to be harder ones than this. Just make sure you understand. Like, I guess the best way to target u substitutions is to really just know your, how should I put it? It's to really know what equation you're dealing with. So integrating sine or cosine. And knowing what to do. Oh, any? Okay, I'm assuming no questions. So we can move on to the next one. Let me get that real quick. So it's going to be, yep, it's going to complain that that's in the way. I guess first I should clear this. What's the best way to clear a huge thing? I have filled. There, okay. All right. They're effectively erased. Okay, so next question. Erasing my part. Right. Okay. So here's our next one. So this is integration by parts. So I don't know if you get access sheet or it's just provided with you, but regardless, you either want to have this equation that I'm about to write out on your equation sheet, or you want to know to look for it. So it's going to be the integral. Oh, I realize I need to change my color back. So the integral of u dv is going to be equal to u times v minus the integral of v du. Really simple equation that you just want to remember because you're going to use it a lot with integration by parts. So we have to first define our u and our dv. And the way you do that is you use, so I like to use one way of defining it. I use Lipit. So L-I-P-E-T. And trying to remember the other one. I think it's like Liate or something. Yeah. The other one is, yeah. Liate. So things you'll notice that are similar between these two is the first two and the last two seem to be inverse. So I'll kind of explain that. So L is logarithmic for both of these. I is inverse trig. So your arc cosine, arc sine, arc tangent, all that. So logarithmic would be your log, your natural log, simply that. P and A are polynomial and algebraic. They mean the same thing. It's when you have like an x squared, anything like that. So polynomial. That's P. And there's E and T. So E is exponential, T is trig. So the reason why they're kind of interchangeable is because a lot of the hierarchy dealing with this. So your U's are going to be higher up, your DV's are going to be lower. The reason being is it's easier to integrate the lower functions. So your P, your E, and your T, or your ATE. It's easier to integrate those than a log or an inverse trig. So the reason why T and E are interchangeable is because your exponential and your trig happen to be very repetitive in integrating them. So for instance, like e to the x, well, it's just e to the x everywhere. So really simple. Cosine, it just swaps between cosine, sine, negative cosine. So that's why you prefer those for your dv and why they can both be interchanged. And so for this problem, we have xex. So we won't have like a weird situation where you have to figure out which one of E or T do we want. But in this case, we're going to have, so x is a polynomial or algebraic, e to the x is exponential. So x is going to be our u, And then dv is going to be e to the x. And then you also want to include your dx here. So now u and v is the first part of this equation. So we have to integrate this to get v. And we'll have v is just equal to e to the x, because e to the x happens to do that, which is nice. Other times you'll have a component in here like e to the 3x, and then you just have messy fractions normally, but normally it's pretty straightforward. So you just have e to the x here. U we already know, so we already have the integral of x e to the x. Not muted, right? Yeah, okay. X e to x dx is equal to x dx minus another integral. So we already know our v, it's e to the x. Our du is going to be the derivative of this, which just happens to be 1 dx. So just have that. And again, we already know the integral of e to the x, it's e to the x. So we end up with, this is all equal to, and you'll notice I didn't put a plus c after I integrated here, because in the end, you just need it at the very end of this problem, because you technically have a plus c here, so you'd have a plus c here, and then the integral of this would provide you a plus c. Well, if you're adding two constants, you just get another constant. So we don't need to worry about that. And then we just get this. Oop. Always find it a little awkward writing in Paint. And there would be our final answer. So integration by parts, make sure you just follow this. Helpful tool for integration of parts or by parts is to set up a table. So I like to set up a dv. So of my u prime. This happens if you have exponential and a trig, because you end up repeating a lot. So you might have to go u double prime, maybe even a u triple prime, though it's rare. You also would have to do this if you had, let's say instead of x, we had x cubed. Then we'd have to keep going until we got a integral like this, where it's not integration by parts. And then likewise, you do the same thing for dv. You do dv, first integral of dv, second integral of dv, and then third integral of dv. So that can get messy notations wise, but it can sometimes help you if you know that this is going to be a long integration by parts. So if our u instead was, let's say, x to the fourth, we would have, so this is x to the fourth, this is 4x cubed, this is 12x squared, and then we'd have 24x. And I guess we'd have to go one further for this. We'd have to go to 24. And then it becomes a straightforward integral from there. So that'd be u. Now, because we have just e to the x, all of these are e to the x. So it's pretty straightforward. Just write that. And then you would run through, make sure you watch for these negative signs though, because once you get to an integral of v du, you kind of have to do the same thing over again, where you have your u and your dv determined, which will just follow the same pattern where it's going to be. So instead u is going your u, your v integral of dv. So your dv now is going to be your v, and then you integrate v again, you take the derivative of u again. But yeah, no, those are for longer problems, which you might not necessarily see. Any questions about this? If not, I will start to find the next question. If anybody has any questions right now, feel free. You can move to another topic if you want one. Like if you have a question on a more recent topic. Let's see. Okay. It's awkward because it has the black outline, but it's okay. Let me get the next question, I guess. Pythagorean identity. You guys don't have to. What is it? Do you have to do trig sub and integrals? Any of you learned that over the semester? Anybody? Because I don't think you guys are doing trig sub and integrals. Pretty sure you're not. Oh wait. Oh, this might be identities. Yeah. I'd probably want to show this one. Okay. Just gotta figure out how I'm gonna show it. Okay, so. I don't even know what I don't know. That's why I'm here. You guys did cover sub. Okay. Some of you didn't. Trying to think. Because this problem I realize is actually identity problems. So when you use, let me just share this real quick. All right. So you have this one. So this is a little different from what I was talking about. This is not trig sub necessarily. Trig sub is when you relate your equation to effectively a triangle, where you might have 1 plus x squared here. So then you know that this would be x. This would be 1, or the other way around. And then you would denote a random angle theta. And then you could say like 1 over 1 plus x squared is actually going to be, so this is opposite over hypotenuse, which is sine of theta. That's trig sub. And so you would use this, integrate using that. I do know we are going to have so the Math Learning Center does host some additional hours this week. And I think the Calc 2 hours are tomorrow, unless your exam's tomorrow. No, your exam's on Wednesday, I think. Yeah, so feel free to come into the Math Learning Center at that time. We will have 3 coaches available. But so that's trig sub. This is more using trig identities to solve for things. So use a combination of these. Typically what you'll do is you'll try and either convert everything over to 1 trig, or you try to, how to put it? Normally you do a mix of U sub in this too. I'm trying to remember how to do this exact one. It's a little awkward. All right, so we can look here. We see that we probably don't have to do any double angle formulas because we don't have double angles. So we can start using our sine squared and cosine squared conversions. So if we use cosine squared, let's see, wait, maybe we want to use this one here. I don't know why my eraser is highlighted. Okay. So one thing we can do is we can use this, but in a slightly different sense. We can say cosine squared of x is going to be equal 1 minus sine squared. So we'll use that here. And don't know if we want to use it everywhere, or maybe. I don't think we can use it the other way around, because then we convert everything to that. We'd have cosine. Yeah, this is all just finding the right path. So if we do that, you would get cosine cubed theta. And then we can distribute this in right away. We'd get sine squared of theta. And then minus sine to the fourth. Something tells me that's not right. Because what happens here, you then, so we this in, we'd have one integral where it's sine squared of theta. Oh, wait. Yeah, I don't think that would work. Let me try and see real quick. I'm gonna try and figure this out. Do we have the key for that? I always can never remember how to start these. At least the first time through. I haven't had many people come to me with questions on these. Yeah. This problem is a side of the odd powered trig functions. Okay. One of the odd trig functions converts all the others to the even powered trig function. Does a U-substitution with that. Oh yeah, it might work because that would do another cosine. Yeah, you'd convert another cosine cubed to another sine. So yeah, if you do that, you would get sine squared of theta, cosine cubed of theta. This would then again turn into, so cosine times sine squared times 1 minus sine squared. Then you do a substitution. I'm just confirming right now. Ah, okay, yeah. So let me quickly fix this up. All right. Yeah, so what you do here is it's actually, yeah. So since this is to the fifth, you do to the odd, you make this cosine to the fourth times cosine. I'm just gonna avoid writing the thetas because just save some time. And you still have your sine squared. So then from here, this is cosine squared squared, and we use this identity still. So we get 1 minus sine squared, and then all of this squared times another sine squared, and then times cosine. And then from here, we can use, yeah, we can use U-substitution because we have sine on the inside of a function, in fact, everywhere. And then we have cosine, which is the derivative. So we say W is equal to sine. Keep in mind that it's just sine, not sine squared. And then dW would equal cosine. So now we have 1 minus W squared and then times w squared. And then this becomes a pretty simple algebraic solve. So I'd always suggest, assuming I don't know, well, with all the things, I'm probably gonna bet that you have a calculator. So from here, it's pretty straightforward solve for most things, but you do need to show your work. So what I would do is 1 minus w. So I would FOIL this out. So let me actually. So since it's first squared, so 1, then you can also do outer right away, but I do 1 times negative w squared times 2. So, and then lastly, the outer squared. Then you'd multiply w squared through it all. You'd get w squared minus 2w to the 4th. And then plus w to the 6th. And then you integrate that. And that's going to be 1/3. And you can immediately substitute in your trig. So w is equal to sine. So we get sine cubed. And then minus 2/5 sine cubed. Or sine to the 5th, my bad. And then last it'd be sine to the 7th over 7. And then plus c. Don't forget the plus c. So that's how you do that. So yeah, what you want to do is you want to leave, so when you have an odd and an even, you want to leave one of the odd left over. Convert all of this to your even. So in this case, sine is even powered. So cosine with its odd power, leave 1, cosine to the 4. And then with that, you would convert, so to the 4th to be cosine squared. Add to the 7th, we'd instead split off 1. You'd have 6 left over. This would be cubed. Same course follows, would be a little longer of an integral, but yeah. Does that make sense to everybody? Sorry if this is awkward looking at too. I'm trying to just show my paint while I'm looking at other stuff. How do you get the w to the 6th? Okay, so that is, all right. So this right here is just from that. So this is me filling this out. So 1 minus w squared. So I out get, and then I'm anything squared. So times w squared is w squared. Negative 2 times w squared times w squared again is negative 2w to the 4th. And then w to the 4th times w squared is w to the 6th. So that's how we get that, and then we integrate. Any other questions? All right. So any other questions about this? Shall I move on to the next bit? Let's see, partial fraction. Yes, if there are no questions, I'm gonna move on to partial fraction decomposition. Just gonna quickly do that. Oh, what about the other? Okay, both odd, both even. So give a good example from that. Let me erase this work. Try to do one real quick for you guys. All right. So let's say we have, whoops, gotta change that. So let's say we have cosine squared and sine squared. All right. So from here, trying to think of the best course of action. Phew. Can't really do a half angle formula with a double angle formula because you'll end up just kind of going back to square one. Trying to remember how to do this. Okay. Typically, I think what you would want to start by approaching with is probably Pythagorean identity again. It's a really good start. I know in the case of, let's see, there's a certain case that I remember. Whew. Actually, I think one of the best course of actions for this, I don't know, you could do, so if we say these are equal to their half angle formulas, we get 1 plus cosine of 2x over 2 times 1 minus cosine of 2x over 2. Whoops. Sorry about that dramatic 2. My hands slipped slightly. So from here, we would FOIL this together. You can basically just FOIL the top. We'd get 1 minus cosine squared 2x all over 4. And then from there, you can just do another, or you can do another half angle formula. This time, because you have 2x already in here, it would be 4x. But you would take this and apply this equation again to it. So on the inside of here, you'd have 1 plus cosine now of 4x over 2. And then if you simplify that out, it becomes an integral where you just have a constant plus cosine. And so you can easily integrate it from there, if that makes sense. Double odd, it gets a little weirder. I think typically if it's double odd, you'll end up with only one of these half angle formulas. So I think it's more common that you'll run into double odd rather than double even. But you'll run into one of these half angle formulas. So you're gonna get like cosine, and then that'll be your like end integral, I guess. I think what ends up happening is you save a sign or something and then integrate. But yeah. So any other questions about that? If not, I can move on to partial fraction decomposition. So I guess I should write on the note here that this is the inside of that. Yeah. All right. I am going to put the new question on here then. Oops. I did not have the right thing. I needed this. Okay. All right. Next question. Should probably be on the right page for that. I really hate the screen share bar that constantly gets in my way when I'm trying to switch tabs. All right. I know it's here somewhere. They went way too far down. Okay. All right, partial fraction decomposition. Let's do it. All right. So you take fraction, we have x, and then x squared minus 3x. And what you want to do is you want to factor this out, the bottom. So you'll get 6 over, and then this you just factor out an x, and you're left with x minus 3. And now this will be equal to a fraction a over x plus b over x minus 3. So with this, so from here, you want to effectively solve for the top. And the way you do that is you multiply everything by x and x minus 3. Sorry if that's ugly. So here, both of these cancel. We get 6. And then for a, just the x cancels. And we get a, x, and then I'm just distributing it right away. And minus 3a. And then for the b, the x minus 3 cancels. And we just multiply by x. So now we have that. So what I like to do is, since we have, so you may say we have 3 unknowns, but only 1 equation. I'm going to turn it into 2 equations and 2 unknowns. So we can imagine that we have a constant plus 0x. Sometimes you'll actually have an x component up here and it becomes a lot clearer to see it this way. And now what we do is we just make an equation for all of our straight constants and then make an equation for all our x's. So our constant 6 is going to be equal to, so ax does not get added to this because we're multiplying by x, so it can't possibly be equal to just 6 unless x makes it, but we're not worrying about that. We have negative 3a, that's a constant, doesn't have x multiplied by it. Ex again has an x, so we don't include it. And now we have, so we have one equation right here. And then we have 0x is equal to ax. This is ignored, we already took care of it. And then plus bx. So now we have 2 equations. We still technically have an x here, but we can just divide by x. And now we have 0 equals a plus b. So we have 2 equations, 2 unknowns. A happens to be really straightforward here. A is just going to be equal to, so we divide by negative 3. A is equal to negative 2. And then since a plus b has to equal 0, b will equal negative a, which will equal positive 2. So now we have our a and b. We're going to take 2 integrals. We effectively split it up, which is why I say we take 2 integrals. So we have negative 2 over x plus the integral. And the reason why we can do this is effectively we're integrating all of that. Since it's addition, we can split it up like this. And then b would be 2 over x minus 3 dx. So now from here, And this is just -2 times 1 over x. Integral of 1 over x is natural log of x. So we get -2 natural log. You'll typically see people use absolute values here. It's always safe to do that. And then plus, and the reason why is because you can't take a log of a negative number. And then, whoops, I did not mean to write an integral sign. And then this, so again, we effectively have a 1 over x situation. We could say it's a 1 over u, where u is equal to x minus 3. Du would just be 1, so there's not much of a reason to do it. And we end up with plus 2 natural log of, so it would be u, but x minus 3. Again, use absolute value signs. And then lastly, because it's indefinite integrals, we add a plus c at the end. Any questions about this? I'm gonna mute myself while the cat scratches a pad. No questions? But he's asking to meet the cats, okay. So from here, I guess I can move on to the next bit. Let's see, what is that? Improper integrals. So no questions about partial fraction decomposition. All right. I am going to erase this. Okay. And time to snipper clip again. This is just quick crash and everything. Say for inner, so we have infinity in there. So we need to figure out if it converges or not. So what we do here is we first kind of, like, you can choose whether or not to do this, but you're taught to effectively change your infinity or whatever, effectively whatever makes it improper. So in this case, if we also had it approaching 5, we would have to consider converting 5. Oh, can we go over questions similar to quiz 14 and quiz 15? Let me look that up real quick. Quiz 14. Vectors? Yeah. This is a really short one, so I'll do this quickly and then I'll do a couple of vector things. Did not know that you guys would like. Okay, yeah, I'll do vectors. So quickly for this, we set infinity equal to b by doing a limit. You'd have to do the same if you had a limit to 5 because 5 is undefined here. So as b approaches infinity. And then it'd be, I'm gonna write it like this because it's easier to read it that way. 5 to the -2nd. That's because it's on the bottom. We can do this. So here, x minus 5 is a simple use, so we don't really need to deal with it because the derivative of the inside is 1. So we end up with just a simple power rule. We have x minus 5 to the -3rd, and then divided by -3. So then from here we plug in b, so we get so it's from b to 10 or 10 to b. So here we get negative b minus 5 to the -3rd over 3. Then you got minus and negative, so plus. And then it's 10 minus 5, 5, negative. Over. As approaches infinity, this is going to be infinity to the negative power, which is effectively 0. So we can ignore that term. And this is just the end answer, which would be 475, I think, because, oh wait, 375, because this is 1 over 125 times 3. So that'd be the end answer. You'd keep the limit throughout all this, but yeah. So any questions on that real quick before I go on to vectors?
What
No?
you have for the integral doesn't match what the key says.
Oh, it doesn't? Let me check that real quick. Stupid bar does not want to go away. Okay. What question was this again?
It's on page 5.
Yep, okay, I found it. Oh, yeah, that's my bad. It's, yep, I went the wrong way. Classic blunder. Make sure you look through your work. So it's -2, you add 1, I subtracted 1. So that's actually to the negative first power. So that's no longer there. Negative still stay. So this is actually just 5 negative first. So it's 1 over. How to get n to equal 1, not 0 for quiz 11, part B. I will move to vectors. Luckily, I can cover vectors really quickly. So quiz 11, part B. So go over how to get n to equal 1, not 0. So when you have an n equals 0 situation, if you want to shift it over, so n equals 1, effectively you can just subtract 1 from every n value. Yeah. So since it's, yeah, since it would be the summation of n equals 0. Yeah. Not exactly that. It would be, so so let's say you had an n squared in here for n equals 0. If you set it to n equals 1 at the start, but you wanted to keep everything the same, you would do this. You just shift it over that way. Clear? Just wait. Okay. Yeah, and so I'm gonna move on to whatchamacallit. Gonna move on to vectors real quick. So let's see. Let's do this one. Ooh, yeah, this is fun. Actually, let me include the note. Okay. All right. So here's the problem we have. Just work is equal to force dotted with effectively the direction you're moving. So we have force is equal to that. So it's a constant force. That's nice. So we have that. And then moves from point P to Q. So if you're moving from point P to Q, our vector, so this will be our, I'm gonna say it's X. So our X vector, so position, is going to be Q minus P, because we're going to point Q, so that's the final. So doing that quickly, we get, this is equal to, I'm gonna use this vector notation because it's faster in my opinion. So we do 6, comma 2. And then this is going to be 12. All right. So work is going to equal force dotted with our x vector in this case. So we have a force vector dotted with that. I just like using x because you'll see it later where you have to actually take integrals of this. That's more Calc 3, but so from here we have 8, 6, or 8, -6, and 9 dotted with 6, 2, and 12. So 8 times 6, 48. -6 times 2, -12. And then we have 9 times 12, which is 108. So you'd add all this up together. So dot products, you add each respective term. You see it right here, A dot B. So if you have A1, A2, A3, B1, B2, B3, you do A1 times B1 plus A2 times B2 plus A3 times B3. So a dot product gives you a scalar, which is a number, not another vector. So any questions on that? Because I can quickly go on to the next question. There are no questions that. And they'll probably give you like formulas. This like physics concepts would be 4. Let me check. Yeah, I believe. Yeah, 144. I didn't write out the answer because I didn't do the mental math, but yeah. Yeah, this would be equal 1 to 144. So just for those that need that, in case I'm not coming across as clear. All right. Rectangle. Oh, it didn't change that. Okay. All right, so here's our next problem. So we have a and a B vector, and we're connecting. Find 0 orthogonal plane. So orthogonal just means it has to be perpendicular. So when you take the cross product, so if you have a vector A, a vector B, so A and B, you do, so what you do is for a cross product, so if you're doing A to B, use your right hand, put your fingers out in the direction of your first vector. So you start with A, and then you curl. So you would try to curl your fingers to the B direction. So in this case, you would kind of have your thumb pointing down. You stick out your thumb in whatever direction that is, and that's going to be your crossed product. So that would be if we took the cross product of A to B. If you took B to A, it would be the exact opposite. So that's B cross A. That's A cross B. So find a non-zero vector orthogonal to the plane through the points P, Q, and R. So for this, what you want to do is you want to pick a common point. I would say pick P. So P will be where you start, and then you're going to have like R and Q. So you're going to find this vector and this vector. So you're going to do R minus P. And then Q minus P. And then you'd take the cross product of those. So let's see, R minus P would be 5, 5, 1. Again, sorry if you hear the screaming in the background. We have some rowdy cats. So we have 5, 5, 1, and then 4, 3, -2. We are running out of time, but I'll try to finish this. So these are our two vectors. And then, I don't know which one we would want to necessarily do. I just say we're gonna cross product. Oh yeah, you can do I cross product. You'll still get a non-zero vector. So the way I set this up is I do I, J, K, and then 5. You put your first vector, so I'm just doing this on top. And then 4, 3, -2, second vector on the bottom. And then you take the determinant effectively, which you'll learn more in linear algebra if you haven't taken it. So to get your I term, you're going to ignore this row and this column and take the product of 5, -2. So -10 and subtract this. So 3 times 1, 3. And that's going to be your I component. And then for your J, again, you ignore this row or this column and row. And now you get 5 times -2, again, -10. But because you're doing J, so you do positive, negative, positive. So this would be multiplied by -1, so plus 10. And it's going to be, so 10 minus 4, but again, because it's negative, you put it. So plus 4, and that would be your J. So get that and that. And then lastly, it's going to be a little awkward. I'm just going to clear that section. Okay. Last, which is where ignoring here. So 5 times 3, again, we're back to plus. So 15, and then minus 5 times 4, which is -20. And that's our K. 20, okay. So that would be our K, and then you just simplify. That would be it. Any questions about that? So remember, dot product is for scalars, cross product is for a vector. Cross product gives you the orthogonal vector to the two other vectors. Your dot product effectively gives you the component. So think of it, if you have a force acting in one direction and you're pushing in another direction, you'd find how much the force is contributing to that direction. That'd be one way. But remember, dot product for scalar, cross product for vector. That's all. I think gonna stop sharing because we are actually past 9. So any last minute questions and try to answer